Welcome, everyone, to the fall series of the Ontology Summit 2024. We have a very exciting series all planned for us, and on a topic that is very much current, ontologies and large language models. Related, but different. So our co-chairs are Andrea Westerinen, and Mike Bennett. And today, Andrea is going to be giving us an overview of this series, and then we're going to have some discussion about it. So welcome, everyone, and I hope that this is going to be a really great and exciting and well-attended series on an important topic. Go ahead, Andrea.
Okay, well, thanks, Ken. First of all, I want to say that I would like this to be interactive and a discussion and not just, me talking or me giving an overview, but other feedback, challenges, other things to talk about, because this is kind of setting us up for the Summit 2024, which usually starts in January. So I just want to say that. So feel free to interrupt me since I'm in screen sharing mode with presentation mode on. I would encourage people to interrupt me, raise your hand or something. If somebody can, or Ravi, if you could help me track questions or anything, that would be much appreciated.
Surely.
Okay, why isn't this? Oh, I'm getting a call. Never mind.
So please put your questions in the Zoom chat.
Oh, that would be good too. So really all I did was say, hey, let's set this fall series up to talk about the specific topics, not of AI in general, but generative AI, large language models, ontologies. And because knowledge graphs are also such a hot topic, include knowledge graphs kind of in this discussion with ontologies, since ontologies are the backing definitions behind knowledge graphs. So we got, I think, a really great set of speakers lined up for this thing, hopefully to generate lots of thoughts and lots of ideas. And my last slide is who those speakers are, but it's really about discussion and debate. So jumping into it, my very broad, very high level overview is different but related, very different. They're in the fields of AI and knowledge representation. But the way an ontology goes about knowledge representation is you sit down and you think about what are the concepts, what are the relationships, what are the properties, what are the rules behind a domain? How do you define that? How do you create that? And put all that together in a framework that's formally defined. And I won't say it has to be written in OWL. It doesn't have to be written in, common logic or anything like that, but it should be defined, communicatable, and somewhat formal in that sense. And the more formal you make it with OWL, with common logic, etc., you can enable more and more machine learning against it. So with machine learning with inference, you can get new information, new relationships, and increase what you know about in the ontology. Knowledge graphs themselves organize and link the data. These are the instances of all the concepts and the relationships in the ontologies. And so I'm lumping knowledge graphs in with ontologies in with this top definition of representations of a knowledge domain. On the other hand, your large language models are all about machine learning. And so I pulled this up. Actually, I think I asked ChatGPT how it characterizes itself. And it said it generated human-like responses. human-like, meaning not human, but it can be text, it can be images, it can be audio, but it doesn't do that just on its own. It just doesn't come up with an idea and blurt it out to you. It's based on what you've asked of it. What are its prompts? What kind of, what they call in-context information you're giving it in the prompt. And where a large language model gets its knowledge, I'm going to put knowledge in air quotes, is by its training data. What are the images? What are the text? What are the audios, et cetera, that have been fed into it so that the large language model can learn its patterns, can learn the connections between things, and output its response based on all of that learning. So because there is so much going on in the press and everybody's talking about it, pros and cons, it's going to destroy humanity or it's going to help humanity. Mike and I thought that would be just a great idea to just say, hey, how can ontologies help this? Or how can we use this massive amount of interest in LLMs to increase awareness of ontologies and knowledge graphs? And hence, this little fall series came to be. The use cases, and I do not at all mean this to be extensive or complete. You'll see all kinds of uses from Q&A, chatbot kind of things to I can extract and summarize text. I can extract information from an image, that kind of stuff. Translation of languages, asking the LLM to do a classification or a clustering based on similarities of things that it has learned, that it has analyzed the patterns, actually generating content, editing content, for example, maybe correcting grammar or spelling errors. But another huge area of interest is this kind of co-pilot thing. Not that ChatGPT or anything like it is a very good programmer right now, but it is learning, and it does help people who maybe don't know how to write Python or don't know how to write a Sparkle query or something like that. It can help them to coordinate their efforts, to learn from maybe possible mistakes, give you a basic framework that you can build out as a programmer. So there are a lot of use cases and potential going forward for this whole generative AI. Now, I tried to pick only very recent publications. So in this last October issue of the Communications of the ACM, there was this, a not very long article on generative AI as an innovation platform. And, it started out.
Sorry to interrupt, Andrea.
Yeah.
Mike Bennett and a couple of more people have put some questions right now.
Sorry, Ravi, they're not really questions. I got off on a tangent and people have been answering back. So I don't know if that might be a bit of a distraction. Although, yeah, the last bit is a good question that somebody's asked, which is how does the work of Doug Lennart and co fit in with what he was describing? Yes, that is a good question. The previous stuff is more of a to and fro, I'm afraid.
Well, I think you're kind of talking about the psych stuff and the microenvironments. And further on in this deck, I tried to talk about hybrid systems and bringing ontologies and LLMs together. Is that kind of what you're asking, Mike, or what the question was about?
The question is MP. We only seem to get initials here.
Yeah, it's Mike here. Yes, from New Zealand. Yeah, I only recently discovered psych when Doug Lennart died, actually. So, and he was in an interview, he was talking very much about this. So I just wondered how much there's an overlap. Is psych actually just a super ontology?
you could say that it was kind of just this huge ontology that was trying to describe the world, describe various what he called micro theories in the world. I think if we went just off on psych right now, we'd kind of be following a tangent. But if you want, just think of it as an ontology and how it might fit together with LLMs, which is kind of the whole back part of this slide deck.
Yeah, it all comes under the broader heading Andrea mentioned before, that ontology doesn't just mean a particular OWL or RDF type of implementation, but everything she's describing that includes psych. And we had a wonderful presentation from Doug Glenn out at last year's Ontology Summit. So if you seek that out and play back the recording, Mike, that will give you everything you need to know.
Thanks.
Thanks. That's a good question, because it actually ties, that is exactly what this fall series is about. So I'm not going to read you the numbers, but I like at least 335 startups are now targeting generative AI. And I think there was on MSNBC this morning, somebody was getting interviewed and it was like, in 10 years, every company is going to be an AI company or something. Oh, CNBC. It wasn't MSNBC, it was CNBC. And a lot of companies, I know this for a fact, are exploring ways to figure out how to make generative AI in general, large language models, help their business environment, help their people, help their clients, help their IT departments. But along with all kinds of people being interested in it, there are definite challenges. So again, this came out, I took some of these quotes right out of this article because I thought it did a pretty good job. I like that first sub-bullet that says the new $1 trillion question is, what is fair use of training data? You know, so if you make a movie and it's starring Humphrey Bogart and it's because somebody did all the learning and analysis of Humphrey Bogart and what he did in Casablanca and everything, is that fair use? These are all questions to be answered. And how much of the training data actually violates data privacy things? How much of your training data or your questions have bias inherent in them? Who owns this material that's being trained on, et cetera, et cetera? Those are all huge questions. Hallucinations, you hear a lot about that, where, you know, the ChatGPT, the large language model, doesn't know something, or maybe in its pattern just decides this is the right progression of logic or progression of words or tokens to put together, and it makes something up. And that is one area where very much things like ontologies in knowledge graphs can be of assistance. Everybody's talking about regulations right now, but another interesting thing, which I thought was very valid to worry about, is this whole environmental impact of trying to train and you know, thousands of hours of compute time and everything that goes into running a generative AI platform. Sorry, I got beeping going on there. And Hinton, when he left his position in May of this year, really was quite expressive in his warning that generative AI would diffuse misinformation, that it would make even make the divides in society even broader, even wider, that people would play off against that, and that we needed these guardrails. We needed the regulation to protect society in general. And the last sub-bullet here is, you know, people are worried that their jobs are going to be gone or, you know, very greatly changed because of large language models. And what does that really mean? And again, maybe there are ways that ontologies and rules-based systems can help with validating responses, et cetera. And those are the hybrid systems that we're going to talk about through most of this fall series, but I'll also bring up at the end of this presentation. And there were maybe 2 more things in chat. Is there something in there?
Yes, I wanted to draw your attention to Bart's question, to Stephen question, and there's one before that from Mike DeBellis. The questions are, maybe you can all chime in at appropriate place. When would be that place, Andrea? You want to, how far are you from asking us the Q&A portion now?
I was just kind of setting the stage here. So I would not take this as any kind of definitive statement about where we're going. Bart's comment about the ontology as a schema for the knowledge graph, that is kind of definitely kind of what I say here. The knowledge graph's organized and linked data as the instances.
Yeah, it started with me posting a quote of something Andrea said that I thought was a really nice distinction, because a lot of clients I talk to get kind of mixed up and think, knowledge graph and ontology are the same thing. And when he said ontologies are the backing definitions behind knowledge graphs, I posted that up for the record, and a whole rabbit hole spun up of people agreeing or disagreeing with that characterization. So I didn't see any questions in there up to now.
No.
Yeah, in my mind, and this is my private opinion, knowledge graphs really need a backing ontology. That yes, you can put together a bunch of RDF triples and query it, but I don't, in my mind, it's not a knowledge graph.
It's just a graph. That's the whole point of a knowledge graph.
Exactly. And that is my opinion. So an ontology is the schema behind it. I like I said, it doesn't have to be OWL. It doesn't have to be common logic. It is the semantic organization, which I think some of my next slides get to. And Steve, knowledge graph and a knowledge base. A knowledge graph is a graph. For me, a knowledge graph, I think, has to have a backing schema. That's an opinion, though. You can argue that it's just a graph.
It's all terminology at that level. So yeah, whatever helps you reach out to the client and make sense of them. Yeah. Okay,
so let me jump into the more substantive parts. But I'm actually really.
But Bart is saying,
I like the dialogue.
But Bart is saying that ontology is the schema. Would you like to chime in, Bart?
Hi, can you hear me?
Yep.
Yeah.
Yeah, thanks. Yeah, it was really just a comment from what Todd was saying and Mike. But I think we're all talking about the same thing. Like schema gives it the structure, defines the nodes and the edges. The fact that it's a graph, I think we all can agree that there's some connections there between nodes and edges. I think the only thing that maybe is questionable is knowledge. So if you can't really reason with it, if it's not designed for that, if it's just maybe just RDF sort of, definitions, maybe it's not knowledge because you can't reason with it. But I think it's open to interpretation. But it was more of a comment, and I think Andrea and the rest have sort of commented on it. So I'm okay with that. Thank you.
Okay, good.
Andrea?
Yeah.
Bart raised a very interesting and important point, that a distinction I think we should make, the ability to do reasoning. Now, many knowledge graphs are not based or not using a well-designed, as Bart said, ontology. And in fact, the way that they crawl through the graph is via graph traversal algorithms, some of which correspond to logical inference, but many do not. And if you have a, as Bart characterized it, well-designed ontology represented in a language that can exploit reasoning, then you have a very different type of, or species of knowledge graph. And the issue of reasoning, I think, should be brought up because in terms of the generative AI, they're using a form of probabilistic reasoning that has yet to be, or I should say, has yet to be described very well, since I don't think they know exactly what's going on. And in conjunction with that, when you have logical reasoning, many of the reasoners out there today, say working with OWL, can give you an explanation as to how they derive their inference. but with generative AI, the explanations that you get may be less satisfying.
You guys have just kind of hit everything that I wanted to talk about here, because this is what's knowledge representation, and it has intelligent reasoning that's efficient. Reasoning is very important. So maybe just,
but not just reasoning, the ability to understand how you arrived at that conclusion, the explanation. And perhaps Kenneth can tell us, we had a whole series on explanation.
I agree. I agree, Todd.
Yeah, we covered knowledge graphs in one summit, and I put a link to the communique in the chat. And there's a very precise definition of what knowledge graphs and knowledge graph systems are, which I think will be quite helpful. We also had a summit on context and a summit on explanations. So there are a lot of really good resources that are available from the previous summits where these were covered very well.
And the reason
I think
for
it'd be
bringing up
helpful
explanation,
to refer to them as we
sorry.
start looking at LLMs.
Yes.
Yeah.
And one of the reasons to bring up explanations is the notion of trust. Can I trust what the system is giving me in terms of a response? Or something that I have yet heard discussed is if we take these generative AI systems and allow them to execute physical actions in the world, are we going to allow them to control or make decisions about control rods in a nuclear reactor, or turning valves on or off in some of the pipelines that are around the world, and other such situations? So if we really can't trust the system, then those sorts of capabilities are not going to be exploited. So the issue of explanation and trust go hand in hand.
Yeah. So Todd, I think we're anticipating a lot of the stuff that Andrea is going to cover. This whole extra conversation on the site started with me just posting a quote from Andrea to put it on the record, and we're kind of very nicely surfacing a lot of the ideas that Andrea's got in this presentation. So
sorry, Andrea.
Oh no, I like it. I can speed through the slides. The reason, and this is why I have this slide up here on discussion focus, that the things that are really important are understanding and knowledge and knowledge representation. Knowledge is different than just knowledge representation, but then this hybrid systems answer to, or proposal to address these issues of trust and hallucinations, but also address the issues of ontologies are hard. So I'm going to kind of jump through this, but what you're going to see in the next bunch of slides is semantic understanding, knowledge representation, and then hybrid systems, and where ontologies are strong, where they might have problems, where LLMs are strong, where they might have problems. And that's what this is about. But I think, Todd, this is kind of stated not quite as cleanly or clearly and from the trust side, but it is from the explanation side that it has implicit probabilistic representations of knowledge of these things that it has observed in its training data. Implicit meaning LLMs are a black box, and you don't really know, how it came up with this idea of Mary is pretty. Maybe it says that. How did it decide this? Where did it come from, those words? Or is it just this pattern that should come next? As opposed to ontologies, which are very explicit, not implicit, explicit about the semantics, about the entities, about how they are defined, how they are related, it's structured, it's logic, it should be logical. And that's two very different things. And I kind of chose these words of explicit, implicit very purposefully to address those issues. but then can hybrid systems help? So I put up, I did a bunch of Googling and looking at papers and everything, and definitions. Semantics is about meaning. And if you agree on meanings, or if you can at least discern what someone is saying, you have an understanding. But if you don't have anything written down, there's just a word, it has no meaning. So it could be different meanings in different communities, something that is very nice to say to somebody or cheeky to say to somebody in the UK could be hugely insulting in the US. Same word, maybe even similar meaning, but the context that it's in can make a huge difference too. And so then you end up with these ambiguities, these misunderstandings, maybe even, driving people apart. And another thing to think about is that understanding comes at these very different levels. Labradors have 3 kind of fur types versus mammals, produce milk. That's like 2 very different levels of specificity. And understanding should help to bridge those 2, situating your details, your abstractions. And I like this idea of creating a whole, creating a synthesis of all of the information into a whole, into kind of systems thinking approach. So if we look at those landscapes, again, ontologies are explicit, they're structured, they have the goals of consistency and verifiability. Very valuable for data fusion, because you can map to this common ontology, whereas the LLM is about linguistic patterns and relationships of the words. And in one of the documents, somebody talked about that the LLM mimics what's in the training data. And I really like that word to describe what an LLM is doing. It's reproducing patterns and it's mimicking what it saw, but it doesn't really understand. Now, can it help a person understand? Yes, but only if a person is then willing to kind of go the extra step and validate what's really true versus what the LLM said that came next in the linguistic pattern generation, right? But again, if you ask an LLM to look at something and find similarities and differences, and only describe what it knows, you qualify its prompt, it can lead to better understanding or better interpretations. Clearly, both ontologies and LLMs have errors. The ontology errors can be introduced by humans when they're defining it. Maybe they haven't looked at the scope broadly enough, brought in all the right experts. But more often, and we had a summit on this a couple of years ago, maybe it was 2016, when you're using the ontology, if you take an ontology and you find something, I found friend of a friend, and I decided to use friend of a friend for robots. I don't know, I'm making something up. You're actually misapplying why somebody created the ontology, how they defined its entities, how they're using it. So unless you understand what were the motivations behind an ontology, you shouldn't just pick it up, because that way you can introduce errors. Now, on the other hand, the LLM can just make up stuff all on its own. Yeah.
Andrea?
Yeah,
if I may, the issue you brought up about this misuse of an ontology brings up an interesting point that I think is overlooked in many cases. It's the issue of scope. So friends of friends ontology, whatever things, has a certain scope of applicability. Similarly, for machine learning and large language models specifically, they have a scope based on whatever they ingested. And I gather that you really can't find out explicitly what has been ingested in some of those large language models. Subsequently, when you go to ask it a question, I think you suggested this, it may be out of scope for that large language model, and you get back some nonsense. Or there may be gaps which also end up with something being out of scope for it. That is, it doesn't have sufficient information. I don't know about knowledge, but doesn't have any sufficient information.
Totally correct. So I kind of put what you said as scope as misunderstanding of purpose, but misunderstanding of scope, misunderstanding of what's included, excluded, et cetera. And that's very important. And that actually comes in this knowledge representation slide, which is a few slides down. And again, as you pointed out earlier, Todd, the LLMs are impossible to troubleshoot because they're black boxes. So getting an explanation of why you said this, you know, is at least not now going to happen. So I was going a bit deeper into semantic differences and kind of understanding, okay, conceptual models versus statistical models that are designed and curated on the ontology side versus just correlations on the LLM side. And I kind of was thinking about it, and I said, well, what if I gave, you know, an LLM, you know, some question about Paris, and it would probably come back with city, France, Louvre, the Seine, but does it really understand what city is? It knows that the word city is correlated with Paris, but what is city in terms of an understanding, really? And then this whole compositionality and relationship thing that, how are parts connected to a whole? How do you define your environment? Ontologies do that really well, but LLMs understand it kind of only in terms of the pattern, patterns that it's observing regarding parts and wholes, the words parts and wholes. You know, not that there is a real compositionality. You know, so like the second sub-bullet here, you know, you can have an ontology that says the left rear wheel is connected to the axle, that's connected to the differential, if you don't have that kind of information in your training data for the LLM or your in-context prompt, there's no way that an LLM can even, you know, start to understand that, or if it may not be that it's more often mentioned the differential and the wheel together. So statistically, that's more common to put together than it is to actually understand the axle too. LLMs don't know how a car is constructed or a plane or a rocket or anything. It just knows the words or the images or the sounds that are statistically related to those things. I asked ChatGPT what knowledge was because there were so many things out there that it was kind of hard. You know, like the Stanford philosophy was talking about knowing how to do something, procedural knowledge of how, know how. And then it also talked about know that. So knowledge about that, of what something is, or that something occurred on October 21st, or, you know, things like that. So this know how, know that is very important. I liked kind of what it said on information theory, that, you know, this knowledge is organized data. Now, I would say that that's not quite enough. I think you have to be a little bit more than just organized. Data becomes information when it has meaning, knowledge when it's understood in context and is useful. I think is useful comes under, I can do reasoning against it. I can apply it in my daily life. Tacit knowledge, very difficult to, you know, to quantify. Knowledge based on experience, on theory. And this was kind of interesting, and maybe the ChatGPT just made it up. Knowledge is recognition, recognition of patterns or understanding relationships. So LLMs are really good at recognizing patterns. The philosophical side of justified true belief, I thought that was kind of interesting. That something is true, that the person believes it, and that they are justified for believing it. The whole "it is true" is very difficult to ascertain. And then there are all kinds of people who have refuted the justified true belief, like Edmund Gettier, who says, you know, that if you have some logical conjunctions You can believe something and good reason for believe it, and it actually is true, but not for the reasons you thought it was. So therefore, it's not knowledge. But okay, I digress. If you look at a knowledge perspective, the ontological knowledge is actually chosen and coded by the designers, the implementers, when they're defining the scope, when they're defining the competency questions, when they're thinking through what should be included. LLMs comes from the input data. And you can think of it as representing human knowledge. Now, it may not be truth, and it may not actually be knowledge, but if it falls under this justified true belief part of things. Neither ontologies or LLMs, no, these entities don't experience things. There's not a conscious understanding. There's no continuous memory. You can say, like Nell, the never-ending learning environment, it doesn't really have continuous memory. It has jumps of interval memories, but okay. And tacit knowledge is very difficult to write down, to describe, and therefore both environments have problems capturing tacit knowledge, which should be, it's very important. You don't want somebody running the Fed and our banking environment that's just right out of college, but you want them to have tons of experience and tacit knowledge that's based on what they've learned over time. Long ago, in a galaxy far, far away, 1993, AMI magazine published this "What's Knowledge" representation. And I thought it was really quite interesting that knowledge representation, now this isn't saying what's knowledge, it's saying what's the representation, is characterized by these roles of being a surrogate. It's a model, it's a substitute. And it's to enable an entity to determine consequences by thinking rather than acting. And then it clarified it and it said specifically by reasoning rather than by taking action. In this paper, they said it had to have a set of ontological commitments, meaning it actually has to define its scope. It has to say what's represented, what's ignored, how is this and why is this ontology being constructed? Then it said it had to allow both intelligent reasoning, but also that it should be somewhat efficient, because it's not a good representation if it's not efficient. And then again, it clarified further that said it represents a way to organize information to facilitate inferences. So again, this is back to this whole concept of reasoning, but the last role that it talked about was human expression, a language in which we say things about the world. Now, LLMs are a language in which we say things about the world. It does capture that. So LLMs don't capture all of these, but they capture some of them. So I kind of broke this down to acting as a surrogate or a substitute for the thing. Ontologies are very good at surrogates, digital twins. Ontological commitments, again, ontologies are very good at that. Not all people who define ontologies document their commitments, though, which is a problem and which should happen. And Todd, I think you brought this up, that LLMs have restrictions on what they know about, what's represented, but that's by selection, restriction, refinement of the training data and the prompts, not by anything inherent in its development. And again, human expression, ontologies define the language by defining the concepts, and LLMs utilize these patterns to output the language. So I kind of went down that path, but then reasoning is hugely important. Formal ontologies, very good at reasoning, very good at detecting inconsistencies, very good at deduction and inference of new facts, transitive rules, symmetric rules, those kinds of definitions. That kind of formality and formality that allows, and the common logic kind of formality allows this reasoning and these inference of new facts, where, and again, I put in this word in italics myself, LLMs mimic it. LLMs are not doing reasoning. They are mimicking the progression of this word is associated to that, or this image is associated to that, associated to that, and you go on and on as you go down the outputs that the LLMs are creating. They're useful when the training data includes the empirical procedural knowledge that's relevant to the prompt. So there were all these papers written, like LLMs can't reason. Well, that Mary lives in the greenhouse and John lives in the blue house. So who lives in the purple house? And if you have more information, if LLMs have seen that before, they can mimic that. If they've never seen anything like that before, not so good. You do have people improving LLM results, though, with this whole chain of thought and tree of thought approaches. And I think Tony Steele, in one of his LinkedIn posts, actually started talking about graphs of thought, which I thought was really interesting. So chain of thought is just, you tell the LLM what you want it to do and how you want it to do it with very explicit steps. Or you ask the LLM, what steps would it take if you were trying to find more logical coherence? Tree of thought, again, maybe a little bit like people, go explore multiple paths. And then what are these likelihoods? What are the pros and cons? How do you bring them back together? LLMs and ontologies can have reasoning errors. Certainly they can contain inconsistencies, but ontologies are really good at, if you tell it to find its inconsistencies, it will, it'll output this is wrong. It has strong or limited reasoning capabilities depending on how well the ontology is defined and what kind of information is given in it. But if you ask an ontology or a knowledge graph to explain why, Dozer is a dog, it can say, I think it's because of this, and tell you the actual triples truths that it put together to determine that answer. Reasoning it over a complex ontology, it is expensive. It can be a problem, just like the expense that's associated with LLMs. But LLMs don't really have any kind of formal logic or reasoning process, and they are very sensitive to, you change a minor word in a prompt, you can get a totally different answer, or you ask the same prompt 4 times, you can get totally different answers, even with temperatures set to 0, like it should be reproducible, but it's not. I want to pause a moment because I'm seeing like 33 chat messages. So does somebody want to jump in there and say something?
Andrea, in order that I can see, it is Bart, Stephen, Wartik, Alex. These are the 3 that I see, and then I will go down later down. So in what way you want to take questions and when? How far are you from the end of your presentation?
I'm actually really close to the end. So maybe let me just finish it and then we'll take questions.
Lot of interesting questions I also have.
There are so many. Trying to just create this slide deck was really hard for me. I liked some of these comments too. Like I went off to see for people who were saying, yes, LLMs can do semantic reasoning. And there was this paper just came out June 23, but they're really saying in context semantic reasoning. So they're doing an analysis of basically saying you're giving examples, few shot learning examples in the prompt given to the LLM and then asking it to come up with an answer, like chain of thought kinds of things. And the findings were, as you would expect, if you're consistent with common sense, i.e. the LLM has seen it in its training data, it performs pretty well. Otherwise, all bets are off. And the recommendations are, as always, there should be some benchmarks, but they actually were recommending this hybrid approach in this paper too, of a graph-based method, a knowledge graph that you have real knowledge encoded in a knowledge base as a graph database, and you can do knowledge insertion, reasoning update, and use that to improve the output of the LLMs. And then they also said, hey, make it better so that if you put information in the prompt, that the LLM actually pays more attention to that. So the first and the last are kind of obvious, but this hybrid was what we actually want to spend most of this conversation, this fall series, talking about. And some examples of this, and we have speakers that are going to talk to all of these things, so that's wonderful. LLMs can extract information and help you map it to an ontology, help you create an ontology, help you create instances in a knowledge graph based on an ontology. LLMs can make ontologies more accessible. For example, by generating a Sparkle query from natural language, by summarizing what's in a knowledge graph, because it does know, LLMs do know RDF, do know Sparkle, do know JSON, and those kinds of things. LLMs can aid in search for concepts in graphs and in ontologies and in text. Ontologies can be used to help formulate the prompts that go to an LLM, that provide some of this in-context knowledge, can be used to validate the responses of an LLM, maybe even to try to, say this response is biased or this response is counter. It has created information that doesn't really exist. It's done some kind of hallucination. I'm not going to read these. Here's a LinkedIn, some thoughts from Tony Steele. LLMs help generate better ontologies, and the ontologies elevate the performance of the LLMs. And Tony is going to be talking in a future session, and as well as John Soa, he's going to be talking at a future session. And he sent an email, and it was more in a private dialogue, not with me, but that I was on, that LLMs aren't incompatible. But, this was a really good quote. The level of precision that's expressed in a typical natural language text is usually not sufficient. And we need formal ontologies. Most general purpose ones don't go beyond the precision that's expressed in ordinary NL. That's the last comment, but special purpose can be made as precise and formal as required. So I just wanted to kind of throw out those ideas, and I'm not going to read you the slide, but that's our speaker overview. So maybe I love that where there are all these questions. I don't, 39 new messages. Maybe somebody could jump in and just start talking.
I can tell you that I can speak to the order in which Bart, then Steve, then Janet, then Doug Miles. There are a lot of questions and comments. So maybe someone can start. Maybe Bart, you can start now. You waited long.
Sure. So it's a
I would
simple
request
question.
everybody to limit to a minute or so, because we have a lot of questions.
So I guess my statement is just that do LLMs perform natural language understanding, or is it just natural language processing? And the example that I gave is of a very simple embedding of text into matrix using word2vec, and it's actually able to identify kind of structural differences between concepts. Like the main example is king whose female is a queen, so it's able to infer things like this. But is that understanding? Does it actually have the semantics behind these different relationships? That's the question.
I don't think you could say that it has any kind of semantic understanding. What it does have is it has the correlation, and it has patterns. So you have the correlation and you have patterns. So, you say husband is to wife So king is to, and so that it's actually, you know, a pattern. Husband is to wife as a couple, you know, go together. That's a pattern. They make it, you know, their spousal. King is to queen actually follows the husband wife kind of thing, but the word queen is more likely associated. There's all kinds, you know, when you think about the number of parameters that these things are trained on, you know, hundreds of thousands of parameters, tens of thousands. You get all kinds of possible patterns that come out and correlations that it can come out. But again, I think it would be come under more of this. I don't know why this won't go up like in here. That if you're consistent with common sense, LLMs perform pretty well. If you're given kind of a more abstract knowledge problem or reasoning problem or understanding requirement, it's not really going to have understanding. But you know, other people argue that it's really there. You know, that there is some not sentient, but you know, understanding.
So Andrea, we will also give responding to a question only 1 minute, because otherwise we won't even have 4 questions.
Okay.
So be quick in your response, kindly. Yeah, next one. Please. Doug Myers, you want to talk? Janet, you want to talk? Stephen Wartick, you want to talk? Anyone, please. Janet.
Yeah, hi. So I think the mimicry word is great. That's very important. And this goes back to the 1950s, where we can learn lessons from what happened with expectations that biomimicry was going to, you know, crack the mystery of what life is and then lead to the generation of artificial life. And Robert Rosen wrote quite a bit on this. There are areas where mimicry is possible and useful, but that is what's going on. It's behavioral mimicry on the surface. It's not structural knowledge. So I think it's helpful to think of LLMs as behavioral and ontologies as structural. And the structure may or may not be appropriate for a given application, but it is a structure. Whereas the expectation that mimicry of behavior is going to lead to some kind of structural, you know, deep theory, and then that's going to lead to consciousness or sentience or whatever. It's exactly the same hype cycle as in the 50s with biomimicry.
Thank you.
Yeah, I love the word mimicry. That when I read it someplace, I was like, oh, that feels to me the perfect word.
So these are the metaphors used in relation to LLMs. Okay, we have Steve Wartick, I guess, is not going to talk.
I think Steve left. He said
Okay.
there was a bye message from him.
And then there is Doug Myers. Doug Myers, yeah.
While you're going through that list, the phrase semantic understanding was used more than once. And I asked, how should I understand semantic understanding?
Well, she did define, if I remember on the slides, the ChatGPT definition of understanding. So if we take that,
No, but specifically the phrase semantic understanding.
yeah.
How should we understand that or interpret that?
I think it's based on meaning.
Which is ambiguous?
Which is, it is a kind of a tad ambiguous. I understand. Okay, more than a tad. I mean, not being not being ambiguous. I mean, being clear, semantic understanding, I went about, you can go down into rules, you can understand details, you can understand abstractions, you can put them together, but I have to admit, I tried to wave my hands and you wouldn't let me get away with that, Todd.
Yeah, well,
Oh.
it's
Oh, I
not
see.
easy.
I missed it. I feel stupid now. I missed the title of the slide entirely. I wasn't looking at the title. I'm sorry, Andrea. But I think the important phrase or term that should be used here in these discussions is interpretation. And of course, I am presenting or relying on the Tarskian view of how we should deal with all these symbols and their relationships to other things.
So you are going more in the formal ontology space when
Well,
you do.
Perhaps, but also in the common use of how we see strings of symbols. Sometimes we call them words, sometimes we call them equations or something else. And what does my brain do? Well, it does something. And in that process, it's interpreting those strings of symbols by relating them to certain, I don't know, sets of neurons or whatever. But for information systems, they are explicitly doing an interpretation of some sort with the strings of symbols that come across in the processor and in association with other strings of places in the memory or on the disk.
Well,
so they are
can
doing a very yes.
Can I make a comment? I don't know any button to push to say I'd like to make a comment, but what I'd like to say about understanding is that the typical meaning that is used as a general purpose is to say that people have a mental model of what the subject is that they're discussing. And understanding means that they are able to take what they hear or see or read or whatever and add that to their mental model. And then they show that they understand by making responses that are appropriate to what the questions were. So understanding means you have a mental model in your head, or your computer system has a mental model of what it knows about whatever. And when it understands something, it adds that information to their mental model, and it shows that it understands by generating responses that are appropriate to what the discussion is about.
Well, John, is it just adding information, adding something or other, or is it the interpretation? And then when the interpretation has gaps, that's when you have to start asking questions?
Yes, all of those above. So that when some information comes in, the person or the system adds some information to the mental model. Now, that information may be correct, it may be approximate, it may be just partial, but it does add something to its mental model, and then it can continue the discussion, and the people who are or the participants in the discussion see whether or not the subject has understood that information by determining whether the responses are consistent with understanding. So different people may understand the same statements at different levels of detail, and you can tell whether they understand by checking whether their responses are consistent with what you would expect.
So without unpacking the whole of ontology, I think what we can say here is, we've had a really nice overview of how there are these two different things. And it goes back to the ancient AI split. There's symbolic systems with grounding and formal semantic theory. Somebody mentioned Tarski and so on. And then there's neural type learning systems where the LLMs are applying that black box learning to a whole corpus of words and the whole network of interactions between those words, none of which are really grounded in any symbolic meaning. And what we're going to see in this series is how these two things, which we've now nicely understood the difference between, how they can feed off each other, how different folks have looked at different architectures that manage to combine what an LLM does well with what ontology does well. And we'll see a number of different ways in which these two very different technologies can feed off of each other and complement each other in interesting and quite novel applications. So this has been a good way of really understanding these differences, notwithstanding that there are lots of terminological and theoretical differences among us on some of the finer details of ontology itself. But I think we'll see more of that as we go forward.
Oh, and Andrea, did you say you had a
overview.
list of the people who are going to be presenting?
Yeah, let me just bring that up. It's
That's the last slide, yeah.
yeah, Deborah
right.
McGinnis is next week, talking about generative AI ontologies and knowledge graphs, the evolving landscape. Then Kurt Cagle and Tony Steele are talking. Then Everin Sirin and Yuan He is talking. Then we have a couple of demos coming up, and at kind of this whole broader thought presentation on the 8th, and then to bring it together. Janet, does that help?
Yeah.
Very much, yes, yep.
And this page would be available on our website as different sessions date-wise, as Ken always puts them. The question I have is that we have talked of these two parts of main theme of the mini series, LLMs and ontologies. Each of them have their own constitutional aspects of what they are consisting of, and also differences. But we have also brought in 2 or 3 related concepts, namely AI, namely knowledge graph, namely what is the context, namely context, explanation, and things around these two. So when we did have a set of series of summits relating to context, explanations, etc. about ontology, we did not have the LLMs in the picture, and knowledge graphs were also a subject. But how to connect all these 3 or 4 things now will be the focus of these lectures that we are going to hear from next week onwards. That's the kind of message I wanted to give.
Yeah, and I did post the slides, and so people can feel free to kind of link to them to take a look at you know, stuff on LinkedIn, what VoiceBox is, which is this natural language to Sparkle, the Deep Onto information. It's all of the links should work fine, including the links to the papers.
Wonderful summary. We have a lot of questions from people, but we will have more and more time. I would request people to give little extra time after 10 in case we run over.
Yeah, well, we've run over already, so
We have run over.
time we adjourn. So thanks everyone for coming. And we're going to have an exciting series. See that there's a lot of discussion already. And next week, we have Ed McGinnis coming, who is going to set the stage. And I think hopefully all of us who's come today will also come next week. And we'll continue this series. So,
Okay, before we log off, just that one question from Marco. I do believe your last one, if neither LLMs nor knowledge graphs allow for compositionality and high contextualization, I think knowledge graphs do. But they need their ontology. So just a real quick answer there.
okay. So bye, everyone. See you next week.